review packet for second semester. I am not going to work on every single problem throughout the entire thing. Just pulling up the key. You can pause the video anytime to check what you need to check, but there will be hints and reminders throughout the video of various problems. So the first part, vocabulary. I'm not going to read this to you. You can read yourself. Hit pause, read yourself. The different forms and such. Alright, you will have the formula for the quadratic formula on a sheet, so you will not have to worry about that. Board's off. Hold on. Okay, let's try this again. Technical difficulties. Alright, so there you go. The bottom ones are, 7 through 9. You're solving by factoring. Okay? So you got to make sure it's equal to 0 first at all times. When you're doing this, like a number 7, I highly suggest you leave, even though it would be easier to move the n squared over this way, I highly suggest that you keep the n squared positive. Okay, so in this case, you want to move these two over here. All right, it'll make your life easier if you're factoring with n squared being positive. Okay, this may not be the cleanest video because I keep orienting the board and it keeps going off, so I don't know what's going on. But number 7, once you move those over, it's a guess and check. You need two numbers that multiply to give you 30 that add up to 11. And remember, if this is positive, that means both signs are going to be the same. This sign tells you what they'll be. So that means they'll both be positive. So they have to add up to 11. Multiply to give you 30, add to 11. On number 8, it's a GCF problem. So you factor out what you can, the biggest number and the letters that are common. And then you set them both equal to 0. Remember, some people forget if there's no plus or minus and it's just a variable out there, set that equal to 0. If you need to put it in parentheses, do so. Number 9, you move 3 over, same thing, guess and check. You need to find two numbers. Now this time, since this is minus, that means you're going to have one plus and one minus. This tells you what the bigger number has to be. Now remember, I've shown you how to do this. If you take the time to put those little marks, multiply the numbers, and guess and check, you have more of a chance of getting it right. Okay, 10 through 12, square root. So for this, remember, you need to get the square root by itself, which in number 10 it already is. So you literally just square root both sides. Please remember, though, that it's plus minus. So square root of 9 is not just 3, it's plus or minus 3. Then you set each of these equal to 0. This got cut off, but it's x minus 1 equals positive 3, and x minus 1 equals negative 3. And you get your two answers. Add 1, you get x equals 4, and x equals negative 2. Okay, now number 11, you have to get the parentheses by itself first. So we've got to get rid of that 2. You cannot square root both sides now. Let's take the square root of 50. Okay, you've got to get it by itself. So you divide by 2, that gives you 25. Then you square root both sides. And then again, remember, it's plus minus 5. So you set it equal to plus or minus 5, two separate problems, and you get your two answers. Number 12, it's ready to go, so you literally just square root both sides. Then you set it equal to 2, equal to negative 2, and solve. Remember, if you need to hit pause at all, go ahead and do it. Okay, quadratic formula. First off, remember, it's got to be in standard form. In other words, set equal to 0. Then you're going to just plug the numbers in. It's always good to identify A, B, and C first, and then plug them in. Now remember, I highly suggest you do this. X equals the opposite of B plus or minus the square root. Do this every time. B squared minus 4AC all over 2a. Put the blanks in first, then go in and fill in for each problem. Okay. Now notice, on number 13, since that's a 0, adding 0 and subtracting 0 is the same thing. So therefore, you're only going to get one answer. On number 14, since this is a positive number, the square root of 121 is 11. That means you're going to add 11 and subtract 11 and get two answers. And then on 15, since that's a negative answer, we can't do that right now, so it's a no solution. You'll learn how to do this later, but not now. Okay, 16 through 18. All you're doing here is just a discriminant. Just a discriminant. Just b squared minus 4ac. You're not doing the whole quadratic. So first you set it equal to 0, like we did before, but then you're just plugging it into b squared minus 4ac. Nothing more. Okay? And like we just talked about, if you get a positive number, that's two real answers. If you get a negative number, that's no solution. And number 18, again, positive, two real answers. If you got 0, like we did on the previous problem up here, number 13, then it'll be one real answer. Complete the square. So remember, not shown on here in the work, so I'll do one of these for an example. So x squared plus 8x. So y equals, let's erase that. X squared plus 8x. Okay. Well, you leave this. Make sure it's set equal. You know, you have any number here moved over. Okay, that's what we did. So you start off by doing half of positive 8. You're going to go up here past the square, so that means you're going to square both sides. I mean, square the 4 and add that number to both sides. Then, just like we did previous, you have a square problem. You're going to square root both sides, which gives you x plus 4 equals plus or minus 4. Then you're going to subtract 4, do two problems. X plus 4 equals 4. X plus 4 equals negative 4. Subtract 4, you get 0. Subtract 4, you get negative 8. Okay, I'm sorry. That was actually the whole problem. So you actually didn't have to do that in this one. I wasn't paying attention. But there's an example for you. This one, all you had to do was find out what that missing number would be. So remember, it's half of the middle number and then squared. So half of this squared is 25. Half of that squared is 144. Sorry, I got too excited about completing the square. Okay, so 22. Just looking at a graph. Okay, the vertex down here. Solutions, also known as X-Intercepts, are right there. It is a minimum. Okay, the range is from -4 up, so it's greater than or equal to -4. The domain is all real numbers because it keeps going. And the equation is, well, you have to work backwards. You have x and x minus 4. You distribute the x and you get x squared minus 4x. Okay, on 23, you have your two intercepts right here, which gives you the point, which gives you x plus 5 and x minus 6. You FOIL that, that gives you your equation, x squared minus x minus 30. Again, all real numbers, and to find out the lowest point here, it's given right here, it's a little bit blurry, but it's -12.5 upwards. Number 24 is an upside down one, so this time you have a maximum. Your vertex is right there, -3, +1. All real numbers for the domain again. This time the range is less than or equal to the ceiling of 1. Your solutions are right here, -4 and -2, which gives you the parentheses, the two binomials of x plus 4, x plus 2. Remember, you just opposite sign. You FOIL and get x squared plus 6x plus 8. Nope, didn't want that. All right. 25. Not a lot of work to do here. You know, since it's in vertex form, your vertex is at 3, 1. Opposite of that, and this number, x comma y. Then you pick a few numbers. Here we pick 4 and 5. 4 gives you, when you plug 4 in, you get 2. So 4, 2, which then is going to mirror image at 3, 2. You plug 5 in and get 5, mirror image at 1, 5. You don't have to do all the points. You just mirror image it. Same thing for 26. Okay, plug some numbers in. You'll find out the vertex is at 1, -9. 2 gives you -8. 0 gives you -8. Okay, you know these points right there, the X-intercepts, and there you go. It's graphed. All right, Unit 6. Your different equations. Okay, linear, exponential, absolute value, v, quadratic, parabola. Okay, more notes you can just read. Again, hit pause if you need to. Again, more stuff to read about what's happening, what the different letters do. So make sure you remember this. Okay, looking at 5 through 7. So find the x-intercept, you plug in 0 for y. Find the y-intercept, you plug in the 0 for x. And you find your two intercepts. Same thing for 6 and 7. Plug in the 0 for x, plug in the 0 for y. That gives you your two intercepts. Matching, okay, A is obviously an absolute value problem. Okay, but they're all absolute value problems. So we gotta do more than that. A, the 10 is narrow. So it's probably going to be 13 or 15. It's positive, so it's still 13 or 15. The plus 1 moves it up 1. So that's why it's 13 is A. B, the 1/2 makes it wider, and the -1 brings it down. So we're looking for wider and down, and it's positive. So 14 is B. Now C is upside down. So that's got to be 11 or 12. The plus 1 moves it up. So that's why it is 11. For D, the 8 makes it narrower, and the -1 moves it right 1. So that's why 15 is D. E, you got a lot going on. It's flipped, so it's got to be 12 because it's the only one left. The 1/3 makes it wider, which works for 12, and the plus 1 moves it left 1, and those all work out. Okay, so what's happening to these? 12 makes it narrower, 5 up. Plus 3 makes it left. -1 on the outside moves down. 1/5 makes it wider. -2 inside makes it right. 0.04 is a fraction, 4/100ths. Okay, so that's wider. Plus 2 on the inside is opposite, so left 2. And the plus 1 on the outside moves it up 1. More vocabulary. Talking about systems of equations. Remember that if they intersect, they have one solution. If they're parallel, no solution. And if they're the same line laid right over each other, then that is infinitely many solutions. Remember, when you take the square root of both sides, it's got to be plus or minus. Don't forget that. That's huge. Okay, graphing. Okay, for both of these A and B on number 5, slope-intercept form. So your y-intercept is 2, slope of 1/3 means up 1, right 3. Do that repeatedly, or down 1, left 3. For for the second one, 6 is your y-intercept, and your slope is -1, which means down, right, down, right, down, right, 1 each. You could go up and left, but you'll be off the chart pretty soon. 6, same thing. Notice they're both 1/3, so they're going to be parallel. And for 7, 1/3 x minus 2. I don't know what's happening here. 1/3 x minus 2 is this line right here. And then -x plus 6 is right here. So it's very similar to the first one, except it's -2 instead of +2. And there's your y-intercept at 6, 0. All right, solve by substitution. This one is screaming at you to do because it's already solved for y. So, like I suggest, circle the 3x plus 6, draw an arrow, and plop it in there. When you solve this, everything cancels, the letters cancel, and you end up with a true statement. Remember, if you have a true statement, whether it's x equals x, 5x equals 5x, 2 equals 2, that means infinite solutions. If you end up with a lie, like 5 equals 7, or 2x equals 5x, then that means it's false, which means no solution. They're parallel. On number 9, it's also already solved for x, so just plop 4y plus 13 in for x, distribute, solve, you get y equals -5. Once you have that, plug this in right there and solve for x. All right, elimination. Now, number 10 would actually be easy to do for substitution. You just have to swap the -x to the right side, -30 to the left side, and get x equals 30 minus 6y and plop that in there. That'd be an easy one to do. But you already have 6y and -6y, which means it's ready to eliminate the y's. You just add straight down, the y's cancel. You get 3x equals -18. Please pay attention to the signs. Get x is -6. Plop that back in either way, either one. If you're going to put it in here, please be careful. I would not suggest that one, even though that's one on the answer key. I wouldn't suggest that one because people often will just write -6 minus 6y and get that wrong. You need to plug it in to -6. It's the opposite of whatever x is. I personally would plug it in here. Multiply by 4, subtract, divide by 6. Number 11. Okay, now this one, neither one cancels right now. Also, you can't make 4 become 5 or 3 become 7. So you have to decide whether I want to cancel the x's with 20 and -20 or the y's with 21 and -21. Pretty much the same amount of work. You decide which numbers. This one's doing 20. Now, -5 and +4 are ready to go plus minus. All I have to do is multiply by 4 on the top, 5 on the bottom. Notice the y's are also 1 positive, 1 negative. So if I multiply the top by 7 and the bottom by 3, the y's would cancel. Either way, I end up with 3, 0 for my point of intersection. All right, Unit 7, Inequalities. Remember, inequalities, you have to use a dotted line or a solid line based on whether or not it's greater than, less than, dotted, greater than equals, less than or equal, solid. You draw your line, you pick a point, usually the best one is 0, 0, unless it goes to the origin. If it goes to the origin, then pick a different point, like 1, 1. If you get a true statement, you shade that side of the line. If you get a false statement, you shade the other side of the line. Then you mark the part that is overlapping. Now notice, reminder, when I shade, I don't darkly shade everything. Okay? I shade this line like with just simple lines like grass growing. I shade this way, and then once I know where they overlap, then I darkly shade. So you can look at the lines. Remember, x equals the vertical line, y equals the horizontal line. And for those, you really don't have to test the point. Greater than is above or right, and less than is below or left of your lines. So you don't really have to test that. Okay, moving on to sequences. Arithmetic and geometric, remember we didn't test this, but arithmetic is basically a linear, and geometric is exponential. We need to talk about the rest of the stuff. Just that basic concept. Okay, there are your formulas on there. So it says, for each sequence given, mark if they're arithmetic or geometric or neither. Give D for arithmetic or R for geometric. And if it's neither, there is no D or R because there is no single pattern or change. Remember, arithmetic is adding or subtracting, and geometric is multiplying. You could say dividing. Either way, you can use fraction or not. Give the next two numbers. Give the next now equation. Give the recursive formula, and give the explicit formula. So your formulas are up there. Plug into. And I'm just going to let you read through the answers here on your own. So notice for number 6, basically it's going times 3 each time, which makes it geometric. R is 3. The next two numbers would be 54 times 3, and then 162 times 3. The formula next now would be next is now times 3. And then D and E give you the recursive and explicit formula based on the formulas given to you. 7 is adding 3, so it's arithmetic. Same after that. 8 is arithmetic, that's minus 5 each time. And 9 is divide by 2, which means you're multiplying your R is negative 1/2. Actually, my bad. You divide by negative 2 each time. So R is negative 1/2. And if you divide negative 50 by negative 2, you get 25. Divide again, you get negative 12.5. Okay, for this one, you're basically matching what's going on. So before we look at the problems, let's look at these. A is exponential decay. So A and D are both exponentials. If you look at A, it's going down over time, so that's decay. D is going up over time, that's growth. B is a linear function that's got a positive slope. C is a linear function with a negative slope. And E is a negative parabola. So, baseball player hits a triple into center field. X is the time elapsed in seconds. Y is the height of the ball in feet. All right? Well, it's going to start when he hits it. It's going to go up in the air and come back down. That's the shape of a parabola. Teapot, boiling water cools when removed from the stove. So as time goes, temperature decreases. That's an exponential decay. 3, electrician charges a fixed fee for coming to your house, then a fixed amount per hour on top of this. That would be B. As time goes up, the cost goes up. C, the opposite direction. You're taking the same amount out each week, and no money's going in. So it's going down the same amount. And then folding a blanket is folded in half, then half again, and then half again. Well, that's exponential growth, because it's doubling each time. And that's what exponential means. Exponential means multiply or divide each time. Okay, real world problems. So, birthday supplies. You're buying streamers and hats. So you can use X, Y, or S and H. It's up to you. Now you're comparing two different trips. So therefore, this is going to be a value, value, value line both times. Okay, so you're comparing two different situations. You literally just read and translate. So the first time you bought 3 rolls of streamers, 3S, 15 party hats, 15H, $30 equals 30. The second trip, 2 streamers, 2S, 4 hats, 4H, for $11 equals 11. Now, you can use substitution or elimination. Elimination is going to be best choice here because everything has a coefficient. You can choose 6 and negative 6 or 45 and negative 45. Most people are going to pick 6 and negative 6. Now, since you're both positive, you have to make one of your numbers negative. Whether it's 2 or 3, it doesn't matter. In this case, it was negative 3. After you do the work, you get H is 1.5. It is okay to get a decimal because this is the cost per hat, and money can have change. So the hats are $1.50, and the streamers are $2.50. Now, this is not exactly correct. You should say hats are $1.50 and streamers are $2.50 because it's a word problem. Number 2, you're comparing two situations again. Two groups of people went to the movies. First group spent $73.50. 2 adult, 3 child. So that's 2A, 3C, $73.50. The second group had 5 adults, 2 children. 5A, 2C, $109.50. Again, you can choose 10 and negative 10 or 6 and negative 6. Here we went with 10 and negative 10. Doesn't matter. Again, decimals are okay because it is a money problem. So $13.50 for a child ticket and $16.50 for an adult ticket. Number 3, now we have a situation where senior class is holding a car wash. It's $3 to wash a car and $5 to wash a pickup. Okay? We're not comparing two different car washes or two different events. We know the cost per car and pickup. 3C plus 5S, and they earn $275. That's the value, value, value line. Now you know there was a total of 75 vehicles, which is C plus S. Number of cars, number of pickups equals 75. This one is good for substitution or elimination. Substitution would be very easy. Just move the S over or the C over. Or you can multiply by negative 3 or negative 5. I always suggest if you're going to do elimination, eliminate the smaller amount. So instead of eliminating the 5, eliminate the 3. You get S is 25 and C is 50. Again, you should say 50 cars, 25 pickups. Okay, quadratics. So looking at this graph, it's already made for you. You're just answering questions. What was the greatest profit earned? Well, profit is on the left side. All right? So it's between 50 and 60,000, so about 55,000. How many things were produced for that? Well, where does this meet? Right there at 100. Now be careful. Don't say the profit was 100 because that's the number of things. Look at the labels on the graph. How much profit was earned initially? Okay? Well, that means where did it start? It started here at 5,000. About how many things do they need to produce in order to make a profit of 4,000? Okay? So, sorry, 40,000, right? Yeah, 40,000. So 40,000 is here, about 50 items. How many things did they produce when they started to lose money? So it was going up, and at 100 items, then the price they started losing money. When they produced 200 things, about how much profit did they make? Well, you just go up to 200, hit the curve, come over, and about $5,000. What's the domain? Well, domain is left to right, so x is greater than 0. Technically, it's between 0 and 200. because that's where it hits 0 again. All right. Vertex. You do the opposite of b over 2a. All right. So a ball is thrown from a height of 4 feet, 40 feet per second. Use the equation. It's given to you, and it tells you what the letters are for. So the 40 goes in front of the t, and the 4 goes in the constant spot. So you write the equation by just filling in numbers. That's it. It tells you v is the initial velocity. It tells you the initial velocity is 40, so 40 goes there. It tells you that h is the height in feet. And it tells you the height was 4, so height goes there, 4 goes there. You're just plugging in numbers. Now, where will it be in 2 seconds? You literally just put 2 in for t. Here, and crunch the numbers. 2 squared times negative 16 plus 2 times 40 plus 4. All right, C. Given the equation, when will the ball be 5 feet above the ground? So just give the equation. So you literally just put, since it says h is height, you put the 5 there, you're done. Okay. When will it reach its highest point? That's the vertex. So you do the opposite of b, negative 40, over 2 times a, which is negative 16. 1.25 seconds. Again, a decimal is okay here. You can have a decimal for time. That's 1 1/4 seconds. What's the height at that point? You plug 1.25 in here and here. Just like we did for b when we plugged in 2. So in other words, if you think about it, if the highest point's at 1 1/4 seconds, when it was at 20 feet in 2 seconds, it was back on the way down. 29 feet was the highest it went in the air. Get the equation for when it hits the ground. That's just like C, except you're plugging in 0. Okay? Not even asking you to solve that. To do that, you would factor it, or plug in A, B, and C in the quadratic equation, and that would tell you when it would hit the ground. Okay. We have a formula here. Says their current rate is 950 an hour, but according to a survey, it seems the number of families will decrease by about 2 for every 50 cents increase in the rate. The function below gives the equation for the club's income based on the hourly rate of x. So you have your equation. It's a negative parabola, negative x squared. A is negative 1, B is 6, C is 475. When will they get their highest income? So again, highest, as soon as you see highest or lowest, you know it's the vertex. So it's the opposite of b over 2a. Negative 6 over 2 times negative 1 is 3. So $3 an hour will be the maximum. What would be the income? You plug 3 in here and here. 3 squared, 9. Times negative 1 is negative 9. 6 times 3 is 18. 18 minus 9 is 9. Add 9 to 475 and you get 484. What income can they expect to have if they charge $10 an hour? Well, if they charge $10 an hour, they'll make $435, which makes sense. If they charge more per hour, income goes down. That's what it said in the beginning of the problem. If they want to make $425, what should they charge? Well, if the profit is $425, you plug it in there and then solve. So you plug it in, you subtract 425, and you get this equation. Right? Now, you want to factor that. Again, as I said earlier, you want your x squared to be positive, so you just divide everything by negative 1. So the 6 becomes negative and the 4 becomes negative, and you factor. If you're not good at factoring, you can always plug it in the quadratic equation. But you factor, you're looking for two numbers that give you 40 by multiplication. 1 and 40, 2 and 20, 4 and 10, and 5 and 8. And then you need to differ by 6. Well, that's 10 and 4. And since we want it to be negative 6, that's minus 10 plus 4. And then when we solve, that gives us 10 and negative 4. You cannot charge negative $4 an hour, so that means we charge 10. What's the domain for the function? Greater than or equal to 0. Because you can't charge negative money. And that's it.